Now in section 1.4, we're going to study types of growth, linear growth versus exponential growth. And you will need some extra paper here because there are a lot of calculations to be done to determine the type of growth. I'm going to bring in some extra loose leaf paper when that time comes. But all right, so here we are. Due to a variety of factors, including fuel price and adverse weather patterns, the cost of many groceries is expected to increase by as much as 5% per year. So let's illustrate this effect on a frozen pizza. That's $5.60. All right, so really what we're doing is if the price of the pizza goes up by 5% next year, what's the amount of the increase and the new price? So 5% of 560. 5% we're going to change to the decimal. 0.05, the word of means multiply. And you're going to do this on your calculator. 0.05 times 5.60, and you're going to get, that's 28. So that's a 28-cent increase. So the price of the pizza is going up by 28 cents. What's the new price? What is 560 plus 28 cents? And let's put our answer in dollars. The new price is $5.88. All right, now here we have a spreadsheet. Now we're going to do some of these by hand. We'll do one by hand. Actually, we'll do two by hand. And once you know how to do two, you would be able to do the others. Let's take a look here. They want us to complete this table for the same 5% increase. All right, so let's look at this small bag of chips. 5% of 75 cents. We know that's going to be, change 5% to 0.05, and of means multiply. And so the increase in the chips is 4 cents. So what is 75 cents plus 4 cents? 79 cents. And that's where we get that new price here. And we would go through this for all of these items, but let's go ahead and let's do the expensive item here, the bag of chicken. 5% of $12.99. We know that means writing 5% as a decimal. $12.99 is the price, and when you do that on your calculator, you get a 61-cent increase. So what's the new price? $12.29 plus 61. That's $12.90. So you would actually do this on a spreadsheet. You would put in a formula. But the new price of the half gallon of milk is $1.88. The new price of the frozen pizza we've already calculated. The new price of ground chuck is $3.66 per pound. Cooking sherry went from $9.49 to $9.96. And our chicken breast went to $12.90. That's for 1 year. So a 5% increase as a decimal is 0.05. So that we include the original price plus the 5% increase. If we were to represent this as a multiplication problem, as we're going to learn, that would be 1, which is the original price, plus 5%. 1.05 is what we would use for a 5% annual increase. We're going to need that for problem number 3. And from now on. So if the price of pizza goes up 5% again the following year, that's going to be 5% on top of the 588, not the original 560, but 5% of 588. Fill in the blank to complete the calculation you'd use to find the price after two 5% increases. This is my starting price, 1.05, and this exponent year is for the number of years. So this is my calculation for a 5% increase every year. And this one would happen to be a starting price of 560. And since my exponent is 2, that would be after 2 years. And so how much would the pizza cost after two 5% increases? We're going to put this in our calculator. Now, the raise to the power button is the caret button on your calculator. And every calculator is a little different. But on my calculator, here's the caret button. That means raise to a power. Kind of straighten this out here. Okay, so on my calculator, I'm going to have 560, which is the original price, 1.05 for the original price plus the 5% increase, and I'm going to press the power button, the caret button, the raise to. And you see now I have an exponent. So after 2 years, that would be $6.17. So for question number 5, here they want us to fill in this table for a pizza that starts at 560 after each number of 5% increases. And let's look at here. We're going to multiply 1.05 raised to the number of years. So this is going to be 560, 1.05 to the first, which we know is 588. And this would be 560, my starting point, 1.05 raised to the second, which we've just done that calculation. So in the third year, that's a 5% increase, not on my original price, but on the 617. So the math calculation would be the starting price, 5% increase, raised to the third. And when you put that in your calculator, you get, now the pizza is going to cost $6.48. 5% increase for the fourth consecutive year. Starts at 560, 5% increase, raised to the fourth. So after 4 consecutive 5% annual increases, that's going to be $6.81. And now here they want to know at the end of 10 years. So if the price of the pizza started at 560, went up 5% every year for 10 years. Try not to get the glare of my lights there. That's going to be 560. I'm going to use my paren button. My parens are right here. Times 1.05 raised to the 10th. So that's going to cost $9.12. I'm sorry. Yes, $9.12. 5% increase after 10 years. My $5.60 pizza has gone up to $9.12 after 10 years. And for question 6, they want us to look at How does the price of pizza after 10 years of a 5% increase compare to what the price would be if it went up by just 5% of the original cost? All right, so what this is asking is my 1 year increase was 28 cents. So you think if it went up 28 cents every year for 10 years, you would might have thought the price would have gone up by $2.80. So what is 560 plus 280? That's $8.40. Huh. No, it's actually wound up being $9.12. So what we're pointing out here is that rather than going up by $2.80, instead, the real calculation, 5% every year, the real difference, the ending price, $9.12 minus $5.60, it really went up $3.52, which is more than if it was just 28 cents per year.